Okay, let's do this question. What expression can we represent with the following model? Each large square represents one whole. So this one big square, this is one whole, and this is also one whole. And how much of it is shaded? A half of it is shaded. In decimal form, how do you show a half? You show it like this. 0.5 is a half. So in fraction, it is 1 over 2. In decimal form, half shaded square is shown as this 0.5. And how many of these 0.5 squares do we have? We have two of them. So do we have an option telling us that 0.5 multiply 2? Yes, we do. Okay, so let's select this. Awesome. Multiply. Hint. Use the number line to imagine moving 0.4 4 times. Okay, so 4 jumps, and each jump is equal to 0.4. 1 jump, 2 jump, 3 jump, 4 jump. Where are we? Can you see on the number line? What is this number? So we are at 1 here, and each of these little lines is a tenth. So 1/10, 2/10, 3/10, 4/10, 5/10, and 6/10. So we are at 1 and 6/10, one whole, which is this, and 6/10, 6/10. Right. So how do we show that? And in decimal form, 1.6. 1.6. So that's the answer. 1.6. 1.6. Bravo. Let's do this one now. 2 multiplied 0.64. Okay, so this is 0.64, 0.64, and we have two of them. Right, so how do we do that? Right, so one simple way of doing this is what we can do is 0.64 multiply 2. 2 4s are 8, and 2 6 are 12. 1 goes here, the dot comes here. 2 times 0 is 0, and plus 1 is this. So 1.28 is the answer. So simple multiplication. The dot, what you need to remember is that right after you're done with 2 times 6 is 12, then the dot needs to go down here, and the rest of it is very similar to how traditional multiplication is done. Hope that was understandable. Let's go and write this answer. 1.28. Check. Ta-da! Very good. What expression can we represent with the following number line? Now there are lots of jumps. 1, 2, 3, 4, 5, 6, 7, 8 jumps. And what is each jump equal to? It is equal to 3/10, 0.3. So this would look like 0.3 times 8. 8 jumps of 0.3. Right? Do we have this? Yes, we do. 0.3 multiply 8. We have this one. So check. Awesome. Which model can we use to represent 2 multiply 0.86? Which one is it? 86/10, 0.86. Oh, so 8600, sorry. Which one? 86. This one doesn't look like 86/10. Oh, sorry, 8600ths, because it has 2 and 2.4, 24 hundredths, which are not shaded, right? So 100 minus 24 is 76. So 76 are shaded in this. What about this one? This one is clearly wrong. It's clearly, I can't understand. These are 2 tenths, and these are I don't know how many hundreds. Let's look at this one. These are, so the non-shaded ones are 14, right? So you can count these 10 and 1, 2, 3, 4, 14. So if you subtract 100 minus 14, this gives you 86, and that's 86 hundredths that we were looking for. 86 hundredths. So this is the figure that we were looking for. So let's select this. Check. Bravo. Okay, use the number line to imagine moving 0.3 3 times. Yes, can we do that? 3 jumps of 0.3. Yes, so that's 3 into 0.3, right? Simple. Let's do this. Where are we? So this is 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, and 9/10. So we're at 9/10. And how do we write that in decimal form? 0.9. Let's do that. 0.9, 0.9. And check. Awesome. Acha. Now, what if you may use the model shown to help find the product? Okay. So we're trying to find out what is 2 multiplied by 0.5. So what is 0.5? 0.5, if you look at this one is 0.5. And 0.5 is half of the square. So what do we have when we have two halves, right? Two halves, two halves. Imagine a Kit Kat, and if you have two halves separately and you could join them together, this is one half, this is one half, and in decimal form this is 0.5, this is 0.5. You bring them together, it becomes one whole Kit Kat. One whole Kit Kat. So this is one whole. And if you sort of want to multiply it using the traditional method, so 2 5s are 10, this goes up, the decimal comes down right here, 2 times 0 is 0, and you add 1, you get 1. So 1.0 is the same as one whole. So that is the answer we were looking for, one whole. Ta-da, show summary. Bravo.